Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. In this section, I want to talk about TCP and some of the applications that it's used with. First, we'll start by explaining TCP and UDP. Transmission Control Protocol, or TCP, allows for something called connection-oriented communication on networks using the TCP IP protocol suite. If you remember back to when we spoke about TCP, it uses something called the three-way handshake. Now, for the three-way handshake, it starts out by a client system sending a SYN or a synchronized segment to a server. The server then responds to the client with a SYN ACK or a synchronized acknowledged segment. Then finally, the client sends back to the server an acknowledged segment or an ACK segment, and then the session's created. If the server is done sending data, then the server is actually going to send a FIN or final segment to the client. The client will respond to the server with an ACK segment and then a FIN segment. Then finally, the server is going to respond back to the client with an ACK segment, and the session's terminated. TCP has a big benefit in that it checks for errors or missing data, and then it can actually request whatever it needs if it didn't get everything. User Datagram Protocol, or UDP, is considered a fire and forget protocol because it's not concerned with looking for errors or establishing a three-way handshake like TCP is. By not having these additional features, the overhead is significantly less than TCP. Some examples of protocols that use UDP include DNS, DHCP, NTP, and TFTP. Now let's talk about some of the specific protocols that exist in the TCP/IP world. Domain Name System, or DNS, is a protocol that allows us to use a domain name to access a system or a resource instead of providing the actual IP address. For example, instead of opening your browser to an IP address of 8.8.8.8, you can just type google.com. DNS uses UDP port 53. Dynamic Host Configuration Protocol, or DHCP, is a protocol that assigns IP addresses and other information for connections. DCP uses UDP ports 67 and 68. DHCP does a lot of this stuff automatically, like assigning IP addresses, so that way you don't have to go in and manually assign it. It's great. Network Time Protocol, NTP, and the lighter version, Simple Network Time Protocol, SNTP, are protocols that synchronize clocks of devices on a network. Synchronized time is important for a lot of reasons, but two major reasons are that authentication protocols like Kerberos need it, and audit logs need it to be accurate when they record events. NTP and SNTP use UDP port 123. A fun fact regarding NTP is that it uses something called a clock strata hierarchy, which basically identifies how close the clocks are to being perfectly synchronized. The main thing that you should know is that the lower number the stratum value is, the closer the clock is to being perfect. So atomic and GPS clocks are going to be stratum 0 servers, and then stratum 1 servers are a little less than perfect, and so on until you reach a maximum of stratum 15. Trivial File Transfer Protocol, or TFTP, is a file transfer protocol without any type of data protection, so don't use it for sensitive information. TFTP is fairly common to use to transfer software updates to devices like routers and switches. TFTP uses UDP port 69. Internet Control Message Protocol, or ICMP, is unique in that it doesn't need a lot of the features that TCP and UDP have. It works at layer 3 to perform tasks like host unreachable messages and router advertisements. Ping is an example of a tool that uses ICMP. Internet Group Management Protocols, or IGMP, enable routers to communicate with hosts and switches to determine a group membership for multicast messages. Now, the group used is called an IGMP group, and devices use a Class D range IP address to receive these messages, which typically start with 224.0.0.x. You've seen all throughout this course that there are port numbers for all kinds of different services and protocols. Basically, there's three major groups of port ranges. We have 0 to 1023, which are known as well-known ports. We have 1024 to 49,515, and these are our registered ports. And then we have 49,152 to 65,535, and these are known as our dynamic or ephemeral or private ports. Something that you need to understand is that a lot of times the ports that we're talking about refer to the server or the system that's actually providing that service. So for example, our client could be reaching out to a server's destination port of 80 for web traffic, but if you look on the client itself, they might have a source port that falls into the registered ports range or the ephemeral ports range. Keep in mind that the client source port gets randomly assigned by the system. If I want to see all the connections that are currently open on a system, I can open a command prompt window on Windows and type netstat, and that's going to show all those connections. If I want to see the port numbers and IP addresses that are associated to those connections, I can type netstat-n. It's going to show me a little bit more information. If I want to see all ports, including those that aren't actively engaged in communications, I can type netstat-a. If I want to see the process ID that's associated with a connection, I can type netstat-o. And then on the right here, you'll see the process ID. If I want to see the process name or the executable that's associated with the connection, I can type netstat-b as in boy. And you can see this is going to require elevated permissions, so I actually need an administrator level privilege command prompt window to run this. So now if I type netstat-b, that will go ahead and give me the information that I'm looking for. So we can start to see executables that are running here. It's not uncommon to have multiple connections spawn as a result of using a service. For example, when you go to a website that serves content like advertisements from other sources, you're going to get multiple connections that are going to open up on your computer system. The other tool that I recommend playing around with is called TCP View, and it's in the sysinternals package. So if you go to www.sysinternals.com from Microsoft, you can actually download this product and play around with it for free. But it's going to show you a lot of graphical information. So process name, process ID, the state, the local address, the local port, the remote address, all that relevant information that you can play around with. It's very important that you can identify what kind of connections are on a system. Imagine if you ran netstat and discovered some malicious executables opening up connections. In general, you don't have to know every single port, service, or process, but the longer that you're in this career field, the more that you're going to become familiar with them. With that being said, you do need to be familiar with the common ports and services that we cover in this course for your exam and in your career. I also encourage you to look on your computer, and if you see a process that you're not familiar with, Google it and see what it does. Is it malicious? If so, how can you remove it? Let's go ahead and talk about some of the common TCP IP applications that you need to know about. When computers originally started becoming a thing, we actually called them mainframes, and the standard way of connecting to them required you to log in locally or to be actually sitting directly in front of the system. Networking really changed the way that we do things because it opened up a whole world where we can remotely log into systems from a different location. Now, this might come as a surprise, especially for younger students, but whether connections were local or remote, they all utilize the command line instead of a graphical user interface like you might see today. The first protocol that allowed us to remotely connect is called Telnet. Now, Telnet uses TCP port 23. Telnet allows you to administer a server remotely and communicate with other servers on your network, which can be configured to require a username and a password to log in. Unfortunately, a huge issue with Telnet is that it sends everything in clear text because it doesn't support any kind of encryption. That means that an attacker can see everything that's happening, including usernames and passwords. SSH is a protocol that should basically always be used instead of Telnet. The function is basically the same as Telnet, except SSH will encrypt both the login information and all the commands and data sent back and forth. SSH uses TCP port 22. Again, the big takeaway is that if you ever get asked on an exam for a secure remote connection protocol or to compare Telnet and SSH, SSH should always be the answer, and that applies in real life too. Email or electronic mail is something that just about everybody has used at some point to send a message, receive a newsletter, or to sign up for some service. Email has clients and servers that handle where the messages end up. Email servers create mailboxes, which are like accounts, and that's how they manage messages and permissions. Some of the common types of email server services that you might see include something called XM, which is a configuration file system, and it runs on Unix and Linux, Postfix, which also runs on Unix and Linux, and Microsoft Exchange Server. Email clients are the software that runs on your computer like Microsoft Outlook. These clients are being replaced by webmail in a lot of situations because it can be easier to access and you don't need to run additional software for it to work. This would be like Google Mail. Email uses layer 7 of the OSI model or the application layer to send and retrieve the messages. Email protocols that you need to know about are SMTP, POP3, and IMAP4. SMTP, or the Simple Mail Transfer Protocol, is used to send emails from clients and between email servers. SMTP uses TCP port 25. POP3, or the Post Office Protocol version 3, is one of the two protocols that's responsible for retrieving email messages from email servers. POP3 uses TCP port 110, but so you know, POP3 is on its way out. IMAP4, or the Internet Message Access Protocol version 4, retrieves email from an email server like POP3, but it's preferred to use because it has additional features like it can actually synchronize mail across several devices, and you can use folders on the server to organize your email. POP3 clients will sometimes allow folders, but they aren't part of the server functionality. Databases are a way to quickly store and organize data. Relational databases store individual records in tables. You might also hear this called the generic term of Relational Database Management Systems, or RDBMS. Sometimes it's easy to compare a database to an Excel spreadsheet because there's rows and columns inside of those tables that you access for data. So for example, if you were a school, you would have a single table that lists all the students with a student ID. Each class would then have a separate table with a relationship using that student ID to store those student scores in that particular class. Then you could see what a student scored in a specific class, or you could return all the scores from all classes for a specific student. Microsoft SQL Server uses TCP port 1433. Oracle SQLnet uses TCP port 1521. And the open source database MySQL uses TCP port 3306. Each type of database has its own query language, but SQL or structured query language is one of the most popular. File Transfer Protocol, or FTP, is a protocol used to transfer files between systems. FTP uses TCP ports 21 and 20, with passive FTP only using TCP port 21 by default. With FTP, there can either be anonymous access where anybody can log in, or you can actually restrict access to require a username and password. Sometimes you might see both, but each will be given access to certain files. When you're connecting to an FTP server, you can log in using the command line, a web browser, or a graphical application. Unfortunately, FTP data transfers aren't encrypted by default, and that includes usernames and passwords to log in. There's two modes that you need to know with regards to FTP. You have active and passive. Active FTP is the traditional method, and with it, your client makes an FTP request on port 21. The server responds using an ephemeral destination port and port 20 as the source port. Since the client system didn't initiate the request using port 20, most firewalls are going to block this type of traffic, which makes this a bad protocol to use if you're using NAT. Passive FTP will respond to the initial request with a random port number so that the client knows which port the server is listening on for data requests, and then the client can start sending data to that port. Since the client's initiating all these requests, the firewalls will understand what's happening and it won't block the traffic. The client needs to be configured to receive these ports and not block them with their firewall, otherwise the process won't work. TFTP, or Trivial File Transfer Protocol, is one that we kind of already talked about, but as a reminder, TFTP is another file transfer protocol that you might hear about, but it basically has no security, so you shouldn't use it except in trusted networks. TFTP uses UDP port 69. Web traffic, or internet traffic, is one of the most used protocol technologies that we have today. The idea is that a web server running specialized software like Microsoft IIS, Apache HTTP server, or Nginx serves up documents to users. These documents traditionally have been written in HTML or a hypertext markup language. HTML5 is the current version of web pages that you'll see today. To access the web pages, you could use a fully qualified domain name like google.com, or you can enter in the IP address of the server. HTTP, or Hypertext Transfer Protocol, runs on TCP port 80 and is used if you ever see your web browser saying HTTP:/ at the beginning of the web page's URL or IP address. A big downside of HTTP is that it doesn't track what a user does on a web page. It basically looks at every page load as a separate isolated event. This is why we have technologies like cookies, JavaScript, AJAX, and server-side scripting that will enhance your web browsing experience, and they can allow for things like tracking your activity. Of course, I'm talking about for good reasons in this context though. Websites running regular HTTP don't provide any security, and they transfer data using clear text. What if you want to provide banking details and it's not encrypted? Websites that want to provide security will enable HTTPS using Transport Layer Security, or TLS, which is the latest version of Secure Sockets Layer, or SSL, to encrypt that session. Keep in mind that TLS and SSL frequently get used interchangeably, but TLS is the current version. HTTPS uses TCP port 443, and you can tell the web page is actually using HTTPS by seeing it in the web URL, but also you can see a padlock icon in the address bar of your browser. Now, I've put together this chart to make it pretty easy for you to see all the common ports, but I highly recommend that you memorize this chart for your exam. In real life, you could Google these ports, but chances are that you'll probably deal with these ports frequently enough to remember them anyways. And these are more ports that you need to memorize.